Good morning, boys and girls. Here is the first lesson of Chapter 9. 9.1 is independent and dependent variables. Our objective, I can write an equation, which you already can do, to represent the relationship between an independent and a dependent variable. So, first of all, I got to tell you what an independent variable is versus a dependent variable. The word independent is usually used when you talk about a teenager. So think about a teenager, and a teenager that is independent likes to do things by themselves. They don't really follow the rules of their parents, maybe, or they're following the rules and they're just kind of out on their own doing their own thing. And now a dependent is someone who follows the rules of somebody else. So you guys at this time in your life are dependent on your parents. You rely on them to help you out, to tell you what to do, to give you instruction, to take care of you, to feed you. I am at this time independent, meaning that I make my own rules. So an independent variable, that's the bossy variable. And the independent variable tells the dependent variable, it's the variable that changes based on what the independent variable is. So let me show you what that looks like. And usually, sorry, I'm moving around here. Usually, but not always, our independent variable will be y, and our dependent variable will be x. Not always, but that's pretty common. So let's take a look here. And in these equations, you're going to have two variables, x and y, or c and m, or whatever it might be, okay? Now here's our first example. Miss Fun burns 5.8 calories for every minute she jogs. So you're going to first write an equation to represent the relationship between the number of minutes she jogs and the number of calories she burns. So first of all, we need to know two things in order for this story problem to make sense, right? What it's asking us to write an equation. So remember, an equation has an equal sign and at least one variable. This will have two variables. It's given us numbers, 5.8 calories for every minute she jogs. Do we know how many minutes she has jogged? Let me switch colors here. Do we know how many minutes she's jogged? No. Could she jog 1 minute? Yes. 2 minutes? Yes. When she jogs 2 minutes, what do we get here? Well, I'm thinking to myself, for every minute that she jogs, I'm going to multiply that by 5.8. So for 1 minute, she's going to jog 5.8 calories will be burned. For 2 minutes, we're going to double that, times it by 2. For 3 minutes, we would times it by 3. So this number here, or this will change, and that's going to be one of our variables. So here, and then depending on how many minutes she jogs, we'll see how many calories she actually burned. So her here's our variable, C equals calories, and M equals the minutes that she jogged. Now, let me go ahead and write the equation first, then we'll talk about the independent and dependent variable. So do we know how many calories she's burned? No. That's represented by our variable C. C is equal to 5.8 times the number of minutes jogged, and we don't know that because that might change depending on the day. So our equation is C equals 5.8 m, or 5.8 times m. And based on how many minutes she's jogged, it will change how many calories she's burned. So in this situation, our bossy variable, or our independent variable, is the minutes. This is our independent. Because depending on how many calories, or how many minutes she jogs, that is what tells our calories how many she's burned. So this is our dependent. It depends on how many minutes she jogs. So if I would say, well, how many calories did Miss Fun burn? You would say, well, that depends on how many minutes she's jogged. So that's the difference between the independent versus the dependent variable. Okay? Make sure you write that down. These are short videos today because we have quite a few to get through. So make sure if you're confused, you ask questions because there's not a ton of examples. Okay, here I have another one. Mrs. Twisdale is going bowling. Now, she has to pay $2.50 for her shoes. If you've never been bowling, you have to have special shoes when you go bowling so that you don't ruin the special hardwood. And then each game that she plays costs $3.25. So for every game she plays, she has to pay $3.25. So she plays one game, she pays $3.25. She plays 2 games, she's got to double that. 3 games, she would triple that. So timesing by the number of games. Your instructions. You are going to, let's see if I can make this yellow. You're going to write an equation and identify the independent and dependent variables. So those are the things that we need to do here. So first of all, we have our variables were already spelled out for us. C is the cost in dollars. G is the number of games. It doesn't say which one's independent and which one's dependent, so we'll need to fill that in. Excuse me. So let's go ahead and look at what we need to do. So if I'm at the bowling alley and I'm looking up at the menu, I'm trying to decide how many games I want to play. I know I have to rent my shoes. I'm looking for how much is my total cost. The total cost is the cost of, I don't know why that, let's see if this will work here. Whoops. Sorry. It doesn't say the words here. That's supposed to say it is the cost of the games. I don't know why that disappeared. And this one's supposed to say the cost for her shoes. Okay. Let's try that again. So the total cost is, first of all, the cost of the games. How much do the games cost? Well, if we look back at our problem, we had 2 numbers. We had she has to pay $2.50 for her shoes, and each game costs $3.25. So I'm looking for the cost of the games. The cost of the games is $3.25. Now that depends on how many number of games I play. Well, I don't know how many I'm going to play, so I need to use a variable to represent that. I'm going to use the variable of G to represent the number of games. So 3.25 times G, which is the number of games I play. Now, I also have to pay for shoes. I don't have to pay for shoes any more than once. I just have to pay one time. So I'm just going to add a $2.50 fee, because if I look back in the story problem, that's how much my shoes cost. She has to pay $2.50 for her shoes. I have to do that once, and then depending on how many games I play, is the $3.25 fee. Okay, and that will give me the total cost for the games. So, which variable, the total cost or the number of games, which one is telling the other one what to do? Think about it. Now, if you're unsure, this number of games, that one is going to tell us the total cost. The total cost is not telling us how many games to play, but the number of games is the bossy one. It's independent. And depending on how many games we play will depend how many dollars we spend. So it's the dependent variable. Okay. Another way to look at this, the independent variable is usually the one that's inside the equation. So you notice it's inside the equation, while the dependent is usually the one on the outside by itself. Usually, not always, but that's a pretty good hint. Alright, so I want you to try this. Here's the variable, or the equation we just came up with. The cost equals 3.25 G, which is the number of games, plus $2.50. How much does Mrs. Twisdale pay if she plays a total of 3 games? Go ahead and pause the video. Try this on your own. You have the number of games she plays, and you're looking for the total cost. Let's see, how much does she have to pay? That means cost. You're looking for C. And this is the number of games. That's your G. Okay? All right, go ahead and try to solve that. Okay, so let's go ahead and plug this in. We don't know how much the cost is, so we're going to keep C the same. C equals 3.25. Now, do I know how many games that I played? Yes, I played 3 games. And I'm going to add $2.50 for my shoe rental. So I need to multiply 3.25 times 3. Let me do that over here. 15, 6, 7, 75 cents, and $9.75. So I had $9.75 just for the cost of the games. plus $2.50 for my shoe rental. Looks like $12.25 is the cost for my entire bowling experience. So I better have $12.25 in order to play 3 games at this bowling alley and pay for shoe rental. Okay, so how'd you do? Hopefully you got that one right. Or try it problem, so go ahead and try this one by yourself. Now Mr. Twisdale has a $3 off coupon for Texas Roadhouse. That's his favorite restaurant. $3 off means that at the end of the meal, they're going to take $3 away, meaning subtracting $3. The cost of his meal, C, will depend on the price, P, for the food he chooses. So you're looking to write, so don't forget to include a $3 coupon in your equation. So you're going to write an equation with C and P, and also representing the $3 off. P is how much his food costs. So if he buys the country fried steak, it'll be different than if he buys a salad. So that will depend, our total cost will depend on the price of that food. So don't forget to include those. Try it on your own, and then we will solve it in just a minute. All right, so let's go ahead and solve this problem. Hopefully you already have it written down on your paper, but I can solve it with you now. So he has a $3 off coupon for Texas Roadhouse. The cost of his meal, C, will depend, meaning cost is our dependent. That's our dependent. On the price for the food he chooses. So this is our independent. That's the one that's being bossy here. Now, we don't know how much that's going to be, but the cost will depend on the price, but then we will also see subtract 3. The reason why is that is representing his $3 off coupon. Okay, so that is your equation. So you could figure out the cost if he bought a $15 plate. If he bought a $15 meal was P, then you would just do 15 minus $3. And his C, his cost, would equal $12. Okay, so this would be your equation, and that's all it asked you to do. It did not ask you to solve it because you can't, because you don't know what P or C equals. It could have asked you, kind of a fun thing to do. What if it said his total cost was $10? How much was the price? So then you would do 10 equals P minus 3, and you would have to say, well, what minus 3 equals 10? Or I can add 3 to both sides, and then I have 13 equals P. So his meal would have cost $13. So that's one thing I love about algebra is once you solve or get your equation, you can plug any number in there and solve it. I just think that's so cool. Well, that is actually all we have for lesson 1. Make sure you write down the notes because I know it's short. You're going to be doing a lot of practice, including your homework pages. So if you need any help, you need to ask me or Mrs. Howell now so that we can help you. I hope you have a great day of learning, boys and girls. Thank you so much for listening.